An equilibrium question. Calculate Kc, the equilibrium constant for the reaction, if 0.2 moles of phosphorus pentachloride decompose in a 1 litre flask to form 0.08 moles of chlorine. So if we write out some simple values first, we start off with 0.2 moles here, and we're definitely producing 0.08 moles of chlorine. Well, because the reaction is a 1 to 1 to 1, if we make 0.08 moles of chlorine, we're going to do the same of phosphorus trichloride. Now, because it's a 1 to 1 to 1, if we start off with 0.2 and we've taken away 0.08, we're going to have 0.12 moles of phosphorus pentachloride left over. So now we can do our equilibrium equation, and Kc is equal to the concentration of products divided by the concentration of reactants. So it's going to be PCl3 multiplied by Cl2 divided by PCl5. Now, because there's no numbers in front of these, then there's no need to put any powers on the brackets, but at later questions we'll meet some of those. So if we substitute those now for numbers, Kc is equal to 0.08 multiplied by 0.08 divided by 0.12. And if we calculate that, it equals 0.05. Now, it's always worth calculating the units now. This is measured in moles per decimeter cubed, moles per decimeter cubed, moles per decimeter cubed. And one above and one below, they'll cancel, leaving just one on top, which is moles per decimeter cubed. And there's the answer, Kc, for this reaction at this temperature. Another equilibrium question, slightly more tricky. We've got a 1 decimeter cube bottle, and we've put into it 5 moles of ethanol, 6 moles of ethanoic acid, 6 moles of ethyl ethanoate, and 4 moles of water. We've sealed them in at a constant temperature. Only 4 moles of ethanoic acid remained. Find Kc. So we've got our reaction here. We're going to do our calculation of change. So we can put in any initial values, calculate the change, and our endpoints. So we know that we start off with 5 moles of ethanol. We've got 6 moles of ethanoic acid. We've got 6 moles of ethyl ethanoate and 4 moles of water. We end up with 4 moles of ethanoic acid. So we know that this one has reduced by 2. Now, just working on this side, first of all, the ratio of reaction of ethanoic acid to ethanol is 1 to 1. So if this goes down by 2, this one will go down by 2, so we'll end up with 3 moles. And again, because this is 1 to 1 to 1 to 1, that means if this has gone down by 2, this one must go up by 2, as must this one. So we end up with 8 moles and 6 moles. So now move on to our equation. Kc is equal to concentration of products. So we've got ethyl ethanoate multiplied by the concentration of water divided by ethanol multiplied by ethanoic acid. So if we plug these numbers in, Kc is equal to ethyl ethanoate is 8 multiplied by 6 moles of water, and we can say it's 6 and 8 because it's happening in a 1 decimeter cube bottle. The concentration is 8 moles per litre, or 8 moles per decimeter cube. If it was in a 2 decimeter cube bottle, then we'd have to change it accordingly. Divided by concentration of the reactants, 3 times 4. And if we put that into our calculator, we then get the answer of Kc equals 4. And if we work out the units, moles per decimeter cubed, I cancelled that by moles per decimeter cubed, and then this moles per decimeter cubed is also cancelled out by this moles per decimeter cubed, so the answer is 4 with no units. Right, last equilibrium question for a while. In a reaction, carbon monoxide gas reacts with hydrogen gas to make methanol. It happens at 700 Kelvin in a 1 decimeter cube flask. We start with 0.3 moles of carbon monoxide and 0.1 moles of hydrogen. When we reach equilibrium, there is 0.06 moles of methanol. Find Kc. So a couple of important things. 700 Kelvin, that's telling us that it's a constant temperature. Also, it's why methanol is a gas at that temperature, so we can work them all out together. So initially, we start off with 0.1 moles per 1 litre of carbon monoxide. We also have 0.3 moles of hydrogen, and we have 0 methanol. What we do know at the end is we have 0.06 moles of methanol. So this is changed plus 0.06. So if this has gone up by 0.06, the carbon monoxide, which is a 1:1 ratio, must have gone down 0.06. Now hydrogen, there are 2 moles of hydrogen for every 1 of carbon monoxide and 1 of methanol, so that has gone down by 0.12 moles. So the final concentrations are 0.04 and 0.18 moles per decimeter cubed. So now we can work out our equilibrium constant by Kc is equal to the concentration of CH3OH, methanol, divided by the concentration of CO, carbon monoxide, multiplied by concentration of hydrogen gas. Now, because hydrogen gas, there are 2 moles in here, then we square that concentration. So if we now put the numbers in, Kc is equal to 0.06 divided by 0.04 multiplied by 0.18 squared, which gives us a value of Kc 46.3.